Okay, so I hope you guys can actually see that from the back there. If not, as I said, just come closer. You can even sit around you don't need a table today. Okay, because I just want you guys to write the answers as it is. So, having a look at this here. This is from which one? 91028. Sorry, just give me a second. Okay, so what I've actually seen is, like, with differentiation, this particular type of question has almost come every year. So if we go back every year from 2017 onwards, there's always been a question about this in every paper. Now, the best way to do is that for each question that you have, start from the left-hand side and work through the most important points. Okay, so do you guys want to actually have a go at this first, or do you want me to actually go through the first one? Go through it? Okay, give me 1 second. Let me pull up the schedule just to double check my answers as well. All right, so what is the first part actually saying here? What do we got? So the first part, I need my pens. Okay, here we go. What was it? 90 seconds, man. So the first part, it actually says f dash of x is equal to 0, right? So what we're really looking for is this part right here. If f dash of x equals to 0, is where's the gradient actually 0? So I'm going to try and do this in different set of colors, guys, so you can kind of see it. So the first obvious one is right there, all right? Because we can say that the gradient is equal to 0 there, right? So we can write that down straight away. That's the obvious one. Is there any other points where the gradient is actually 0? The flat line, that's right. The flat line from here, and because how it says the arrow is actually pointing towards the left-hand side, we can actually say that x has to be less than 2. Now, would you put that as less than or equal to 2 or less than 2? Yeah, you would actually put less than 2, because at that point right here, it's a sharp point. If it's a sharp point, we can't actually differentiate at that point. Okay? So in this case, there's only two answers, which is x is less than positive 2 or negative 2? Negative 2 and 2. Now, the second one is saying, when is it f of x is continuous? F of x is continuous, but not differentiable. Now, continuous means is like you can actually take a pen and you can actually go over that particular line or point or whatever it is. So in this case, if I start from the left-hand side, I'm going to go through this in this color. So I'm going through here, from negative 4, get to this point. It is continuous, isn't it? Because I don't have to take my pen apart, it just keeps drawing. But however, that point right there, I can't differentiate. So we're looking for continuous and not differentiable. So that means negative 2 is 1 point. As I keep going, it's not continuous, not differentiable, and then not continuous here. And then this point right here is continuous, because I can actually draw this without taking my pen off. However, because it's a sharp point, it's actually not differentiable. Is that all right? Okay, so I've already used red and green. I'm going to take the colors out so that we can kind of do the rest of the part. Now, the next part it's actually asking for is f of x is not continuous. Okay, so we're basically looking for breaks. If I draw from the left-hand side to the right-hand side, I take a break here, I take a break here, but the rest of it I can just keep going. So how many points are there that it's 2 points? And that's negative 1 and 0. Okay? Now we look at, again, sorry, I got to get rid of all of this. Now we're looking for f double dash is less than 0. What does that actually mean if it's less than 0? Yep, so remember this. The other words that are quite useful is, why is my pen not working? You've got concave up. So that generally looks like this. We also have concave down, which looks like this. So in this case, f double dash of x is less than 0. F double dash of x is greater than 0. Now, also remember, if f double dash of x is greater than 0, do you remember how we do that second derivative test? If it's negative, then it's going to be a maximum point. And if it's positive, it's going to be a minimum point. Do you guys remember that? So if you look at this, that right there is a minimum. That right there is a maximum. That's another way to try and remember if you forget the f double dash of x. So in this case, we are looking for at what point is it actually concave down. Now that actually from all the way from 1 going all the way to positive whatever infinity. So we can actually rewrite this as, I should have used a different color, but I can actually say as long as x is bigger than 1, it's going to be concave down. Is that all right? Now the last question is the limit one. Okay? In this case, we're looking for what is the value of limit as x tends to -1. So we go to -1, which is right here. Okay? Now it's asking you for limit of x as it heads towards -1. So you got to look at it from both sides. What's happening to the y value when I come from both sides? And as you can see, it's heading towards +2. So that's what that answer there is going to be. Is that all right? Okay. So that's from 2017. What I'm going to do is I'm going to put up 2016 question up for you guys, and I'm going to give you guys a few minutes to try it out, and then after that I'll go through the answers. All right. Now we did do this about a few months ago, but I guess kind of people can easily forget. So it's just you got to keep practicing them. All right. But what I have noticed is that this question every year it's kind of come through. So it's a pretty safe bet, but you never know what these guys are going to do. But still, it's something useful to have. This one here. So first off, we have f is not continuous. So start from the left-hand side. 1 break, 2 breaks. Okay, so we should have got -1 and +1. All right. Second one, we have f of f is not differentiable. So that point there, 1. I shouldn't draw that. Sharp point, hole, sharp point. 4 points you should have got. So all 4 of them, you've got -2, -1, +1, and 4. Then we're looking at f dash of x equals to 0. So flat line, -4 is 1. Where else? Oh, you have 3 up here. And then everything after 4. So x has to be greater than or equal to or greater? Awesome. 3 things there. And then we are looking for, go with rainbow pen just for the hell of it. We are looking for f double dash of is less than 0, which means the shape is going to be concave down. Now where is that going to be between, guys? 1 and 4. Yep, because that's my shape right there, that's concave down. Okay, and finally, what's the value of limit as x tends to -1? Right there. So that's going to be 1. Because that's at 1, dude.
Oh, I see. But, sir, that's what I don't understand. Like, why is it that point, not the other white dot?
Oh, you mean the black dot here?
No, because it said what is the value of limit of fx?
Yep.
Why is fx -1?
It says under limit.
Oh, here, Matt. Under here, right? It says x is -1.
Oh, okay.
Yeah, sorry.
Anti-Asian.
Now, like all the limit questions will have like something x tends to towards, and that's why we go towards that.
Except our mock exams.
A?
They didn't print it properly.
What do you mean A? X, for 1. Hang on. If you get 2 of them correct, 2 correct answers gets you achieved, 3 correct answers gets you a merit. So when I say 3 correct answers, there is altogether 1, 2, 3, 4, 5 questions there. So I think if you get 3 questions correct, they're looking for a merit. This is from 2016.
Wait, sir, just to clarify again, limit is just asking for the y value of the fx.
Yeah, as x goes towards that value. Yeah. Okay, I'll pull up 2015 paper.
It's not asking for the x value.
No, because they're given the x value. X is going towards -1. So if you look at it, it says x is going to -1. So then maybe I should have done it like this. What happens to the y value as I come close to the x value of -1? Let's have a look at. Yeah, that's why I drew on the line itself, just to kind of make it simple. Do you have which question it was from 2015? Where? Oh. Okay. 2C. So this is from 2015, guys. Of course, you have to go on top. Okay, I might. Yeah, as predicted. Give me. Is that gonna work? Yeah, that's gonna work, isn't it? Okay, can you guys try and do these questions here? I think at the bottom there you can see the last question. Actually, no, you only need it up to here. There you go. Try this question here. Okay, so first issue that we have here is f of x is not defined. That means we're looking for a point where we can't actually find a particular y value. Is there one? Yeah, the dotted line. Because it's an asymptote. You can't really find f of x on when x is equal to 1. Because it is an asymptote. That's number 1. Number 2, f of x is not differentiable. So starting from the left hand side, the first point being -1. The asymptote. And number 2. So we've got -1, 1, and +2. Then we have f double dash of x is greater than 0, which means we are looking for concave up. So the only place I can look at concave up is this right here. And our limits, well, it's going to be between -1 to +1. Then we have f of -1. F of -1, in this case, we've actually got 2 things that are happening here. What is f of -1? The black dot, which is 3. Okay? And then if you look at what is the value of limit of x tends to 2, as we come close to x is equal to 2, we're coming at 2 different points. So therefore, in this case, does not exist. Okay? So for this question here, you needed 2 correct answers for achieved, and you needed 4 correct answers for a merit. Even though there's only 5 questions, you actually needed 4 correct. And I know in the previous question we did, there was only 3. Yeah, they always change it up, guys. So you want to make sure you can actually nail all of them. All right, I've got time to do one more. Okay, so let's put this up here. Sorry, just taking a bit more time than usual. And my questions. Why? Why? Why won't you work for me today? What did I do wrong? Now it's been one of these crazy days, man, like honestly. Alright, here we go. Let's hope this works. You guys okay with that, right? This is 2015. All right, here we go. Number one, f of x is not differentiable. We can see that you can't differentiate at -2. Where else can we differentiate? -1 and +2. So yep, those are our 3 points there. And then we've got f double dash of x is less than 0. So we're looking for concave up or down?
Down. Sad.
And in this one, you can kind of see that it has to be x. What will it be?
Where did you go such a small name?
So you are saying,
5.75.
is that right? Yeah, but here's the thing, guys. We don't know, like, see how this graph here, it's like extending outside? We'll have to assume that it's actually endless. So that means it's actually not between 6. It's x is less than -2. Because we don't know what's happening before, like when it's -7 or -8. It could potentially be going down.
-2 is endless as well.
Yeah, but the thing is, -2 is an asymptote, right? So it's going to keep going down, but it'll never touch -2 though. So that's why we are comfortable putting x is less than -2. Is that all right? Okay, next one is f of x is not defined. That's when it's an asymptote, and we can see that it's -2. What's the value of f of 2? 4?
Yeah.
Then lava pen for this. Limit of x tends to -1. What'd you guys put?
3.
Huh?
3.
3. Good. Well done. That's basically it, guys. I'll chuck it up on this video as much as I'll try and upload it tonight. But thank you. And pray that a question like this comes in your exams. And that you'll nail it.
The 1 year that I planned.
Could be this year. Just because it's like Jin's doing it. I know. All right. Cheers, guys.